Hi everyone. This is a nice LR set on based on averages and allegations. So if you look at it in that way, a bit of comparison to begin with, weighted average and all. But after that, while solving the questions, if you're good with allegation, it becomes very easy. So let me start with the premise here. So there's a accreditation that is going on various colleges that we have. So there's four parameters rather. We have faculty quality F, reputation R, placement quality P, and infrastructure I. These are the parameters. And using these parameters as weights, the final accreditation is given on the basis of the total score obtained. So this table is a little the font size, I believe, is a little on the low side, but I believe this can be read. I will dictate whenever it's required. But these are the range in basis of which the particular accreditation is given, AAA or BA or BBA, whatever. So that will be dependent on the question itself. So that is one range that we have and a specific accreditation. Also, there are various grades that are given for each parameter. So these grade points will give us the overall grade using the weights as F, R, P, and I. So you have 50 points for A, 40 points for B, 30 points for C, and 20 points for D. F carries no point. So let me quickly write this down. So we have A, B, C, D, and F. So we have 40 points, 30 points. No, sorry, 50 points. It starts with 50 points, 40 points, 30 here, 20 here, and 0 here. So this is the grading that is available. And depending on the weights that we have, so the net accreditation is obtained. So these are the weights that are given: 0.1, 0.2, 0.3, and 0.4 in some order. So this is the allocation. I mean, whenever you're reading this premise, you should be able to understand the four parameters that we had. So F, R, P, and I. These are going to carry certain weights on these numbers. So this will be in some order. So we don't know which one is which one. So that is obvious. This is pretty obvious, right? I mean, this is something we have to allocate. So this is what is given. This table we will require later on when we are calculating the overall accreditation of a particular college and all. But these 3 points are the vital ones which are mentioned. So let's go with each of the points. This table is again it gives us the specific grade on these parameters for the 8 colleges that we are focusing in this particular LR set. So the first point tells us that high Q, that is H, is better than best ed, so that is B. So we are comparing H and B. So let me do this. So let me just write H and B here, and let me write the grades of F, R, P, I as given in the table. So I'll just write H on top because H is better than B. It will be easy to compare in that way. So H has C, D, D, B in order. C, D, D, and B. I hope you can see this row. That is H. B has B, C, D, D in this order. So we have B, C, D, and D. So this is what we have, right? Now, notice something. I mean, we know that H has got a higher overall score than B. That is mentioned, right? High Q is better than best ed. So the comparison will be only when there is a difference in grade. So these two is not creating any difference in the overall score, right? Because it's the same weight. P has a certain weight, right? So whichever weight it is, that difference is zero from there. So where the difference coming from? So H has to be more than B. That is already given. You can write a whole equation, but I'm showing you a short technique. So what I'm going to do is I'm going to calculate H minus B, and I'm going to write that as C greater than 0, because that is what is mentioned, right? H has to be greater than B. So I'm just going to take the individual differences and I'm going to multiply with F, R, and so on. So whatever are the weights. So as of now, I'll indicate these variables. I mean these as the variables. whatever that can be replaced by 0.1, 0.2, 0.3, and zero point 0.4. We are coming to that in a while. So first, the F column. So I hope you can see that H minus B is minus 10, right? Because C is 10 points lower than B. You can check it from here. So 30 minus 40, that is minus 10. So for H minus B, we have minus 10 F. R is D minus C, so that is 20 minus 30. So that is another minus 10. So we have minus 10 R. And for I, we have B minus D. So B minus D will be plus 20, right? So we have plus 20 I. Now this is greater than 0. So this is the difference of the overall scores, and this should be greater than 0. So if you just resolve this a bit, you'll find something like this. 2I should be greater than F plus R. Now this itself is going to tell me a lot of things. Notice it in this way, compare it in this way. See, the parameter weights that we are having here, I mean, these are the numbers, right? So we have 0.1, 0.2, 0.3, and 0.4. You can treat them as 1, 2, 3, 4 if you want to do that in convenience. What I'm noticing is this is something, I mean, relatable to an AP series, right? What I mean by that is, suppose this would have been 2I is equal to F plus R. Then F, I, and R would have formed an AP, where I would have been the middle term. But here 2I has to be greater than F plus R, right? Because these are, I mean, here we are relating three different parameters, so we can do this very quickly. The idea is, if I consider three consecutive numbers, so if I consider 0.1, 0.2, 0.3, or I consider 0.2, 0.3, 0.4, then in both the cases, 2I will be equal to F plus R, right? It will not be greater than F plus R. So what it automatically implies is you cannot take three consecutive numbers. So if you can't take three consecutive numbers, it's very easy to understand that 0.1 and 0.4 has to be selected for these two numbers in order to have that 2I greater than F plus R. So 0.1 and 0.4 has to be selected for these two numbers, right? The other possibility is that I has to be, or let me put it in that way, that is one case, 0.1 and 0.4 selected for F and R. The other possibility is that I will be itself greater than both F and R. So these are two different possibilities that we have, broadly speaking. But if I pick 0.1 and 0.4 for F and R, then that reduces the possibilities for I itself. So this thing should strike you immediately. So this is from the first point. Now let me just erase this and I'll get to the next point now. Okay. Second point tells us that bested is better than cosmopolitan. So B is greater than C. So let me again do the same thing. So I'll put B up and C below it. And the order is F, R, P, and I. As it is in the table, I'm just taking the same order. I don't want to overcomplicate these kind of things. And let me put the grades in this particular order itself. So B will be B, C, D, T from the table here. And C is B, D, D, C, right? So that is, let me write this here, B, D, D, and C. Now, as we did in the previous case, we know that B minus B has to be greater than C, implying B minus C has to be greater than 0, the overall score. Now again, check in this case, two columns are irrelevant, the F column and the P column. These two are both irrelevant. Now, this becomes a little interesting. So if you check, this has minus 10 deviation. So you have minus 10 times R. No, sorry, we are doing B minus C, right? So the other way around, sorry, C minus D. So C minus D. What I meant by B minus C is these two things. So C grade minus D grade, that's plus 10 actually. So we have plus 10 R. And this is D minus C. So that is minus 10. Minus 10 I. This should be greater than 0. So this, just look at this. I mean, this thing you could have done without even writing this up. We can directly see that R is greater than I. Now remember the two cases that we talked about from the first point. If I pick up I greater than both F and R, then this is not possible, right? So R has to be greater than I. Then it is that other case that I talked about. So I've kept that marked as well. So 0.1 and 0.4 has to be picked up, and I has to be somewhere in the middle, right? And also, if you pick up R greater than I, so R has to be this 0.4, right? So this has to be R, and F has to be this 0.1. right? This is the only possibility feasible, because again, same idea. If you put it in this way, or if you're not getting this directly, you can do it in another way. I'll just show that once. Just change this a bit. So we can write this in this way, right? I hope you understood this. I just transferred the f on this side and took one of the I on this side and kept the inequality sign as it is. So I minus f is greater than r minus I. Now, because r is greater than I, so r minus I is positive, right? So r is greater than I, we already know. Now check this out. I minus f is also coming out to be greater than 0, right? So I also has to be greater than f. So now I hope this is obvious. So I has to be in between f and r. If I is in between f and r, then the only feasible one is, as I said, I mean, it cannot be 3 consecutive ones, then it will form an AP. So the only way it is feasible is f has to be 0.1 and r has to be 0.4. So f is 0.1 and r is 0.4. So the total is 0.5, right? Now, if you pick I as 0.2, then 2 times of 0.2, this will be 0.4. But this side is 0.5. So this is not greater, right? This is incorrect. So you have to pick I as 0.3. In that case, this will be 0.6 and this is 0.5. So 0.6 is greater than 0.5. So this has to be I. So effectively, this has to be P, right? So we don't even need the third information in this case. We can fill this up with the first 2 information only. If you want, you can verify this yourself. Do the same thing for the third point, and accordingly, we can figure this out. So this is all we require, or all we can gather. I mean, this was the main thing that we had to figure out, right? So this allocation. So now let us get into the questions, and we'll check those questions one after the other. All right, so let us get into the questions. Additionally, what I'm going to do is I'm just to get some space here. So I'm just going to write this weight of FPIR in this order as in the table on top of it. So F is 0.1. And also most of the cases it will be weighted average. So I'm just writing 1, 2, I is 3, and R is 4. Just remember, I mean, when we have to figure out exactly, just remember that this will be 0.1, 0.2, 0.3, and 0.4. So I'm just writing the ratio here, that's all. So let us get into the questions. Question 1 is about the weight. So weight of the faculty equality parameter. Faculty equality parameter is 0.1. This is 1 here. So remember that it will be 0.1. So option B is the answer. How many colleges receive the accreditation of AAA? Now, if you have to get AAA, so let me get that table as well. Yeah, so AAA, you can see that the overall score required is greater than equal to 45, right? So we need an overall score of greater than equal to 45. Now, understand one thing before we start solving this. In order to get a overall score of greater than equal to 45, you need sum of 50s, right? I mean, you need some of the grades as A. I mean, only with the combination of 40, 30, 20, and 0, this basic, very basic idea of averages. By combining 40, 30, 20, and zeros, you cannot make a 45 as the final weighted average, right? So in this case, we need some A's. So what I'm going to do is I'm going to strike out those colleges which are not having A anywhere. So Bested is ruled out. So this is out. Cosmopolitan is out. Dominance is out. Global is out, and HiQ is out. So these are definitely out, right? The remaining ones are A1, Education Aid, and Fancy. So let us go one after the other. So I'm going to use weighted average techniques. In this case, I'll use allegation. I'm going to use reverse allegation to be precise. And let us see how to do that. So if you look at A1 first of all, so the A1 college, all these 3 are A grades, right? So that's I mean, all of these 3 combined, you will have a weight of 50 or average of 50, right? F, R, P all combined. And I is 40. Now check the weights. Now this is why I've kept these numbers only, because I don't need that 0.1, 0.2. I just need the ratio of the weights, right? So FRP is a total of 7. So this contributes to 7 and this contributes to 3. So that is what we have. This is the ratio, right? Now check this out. I mean, this is the reverse way of using allegation. You can use offset or weighted average also, but this is a little faster. The difference here is 10 and the sum here is 10. So the difference and sum should always tally. Once you know that, then it is very easy. Once this is done, all you have to do is just remember that allegation is cross differences. So 50 and the average, net average here, will have a difference of 3, and 40 and this average will have a difference of 7. So obviously the average of 50 and 40 should lie in between 50 and 40. So it should be either 50 minus 3 or 40 plus 7, whichever you prefer. So this is getting 47, right? So A1 is getting 47, which actually qualifies under the AA category. So that is what we're looking for, right? AA. So greater than or equal to 45. So definitely qualifying. So A1 is definitely qualifying. Let us do the same thing for the remaining. So education aid. So I'm just writing ed. You have A, and A here. So that's a 50 contributed from F, R, and I, a net weight of 8. And this is 40, a net weight of 2. Now, again, I mean, you can calculate this in the same way or observe this. I mean, when we had a ratio of 7:3, we are getting an average of 47. Now, since the weight of 50 has increased, it has gone from 7 to 8, it is bound to increase, right? So the total, the net average in this case will be higher than that of A1. So ed is definitely, so education aid, this is definitely qualifying under the AA category. So this is also qualifying. And let us finally look at fancy. So I'm just taking this part off. So fancy here has AA in couple of them. So AA is for, sorry. Yeah. So AA are for 1 and 4. So that's 5. And 40 is also 5. So 5:5 is 1:1, right? So that's simple average. 50 and 40 simple average is 45. So fancy also qualifies. So each of these 3 are actually qualifying. So answer for this will be 3 colleges. Okay, question 3 is asking what is the highest overall score among the 8 colleges? This is something we already figured out, right? There are 3 colleges. In the previous question itself, we figured it out. There were 3 colleges which were getting in the category of AA. And out of those 3, education aid had a higher one than A1, right? If you remember. So that was having a higher weight. So let us quickly calculate for education aid. So I'm just writing this as E. So we have 50 contributed from F, R, and I. So that is a 1, 4, and 3. So this was the chart, if you remember. And 40 was contributed by a 2, right? So again, difference of 10, sum of 10, that is tallying fantastically. So don't reduce this ratio. So you have either 50 minus 2 or 40 plus 8. So whichever way you can figure out the highest overall score as 48. So that is it for question number 3. 4 is asking for how many colleges have overall scores between 31 and 40. Now this is interesting. So between 31 and 40. Now, in order to get 31 and 40, you need to have some C's and all, right? We don't have to check those colleges which we already know that are getting under the accreditation of AA. So that A, E, and F. These 3 colleges we don't have to check. So we can strike these off directly. And also similar to the thing that we did in question number 2. In order to get in the range of 31 to 40, so we can visualize this in this way, that in order to get 30 or more, you need to have some C's, more of C's, B's, in order to get in this range, right? So let us try to understand how to do this without too much of calculation. So if we consider, let's say, first of all, this global thing. Global thing, I actually don't have to evaluate this. I can straight away cancel it. Please understand this why. So what I'm observing is for global, the only C that you get, now C is 30, right? C is exactly 30. The only C that you get here, the only this thing parameter which has a C is 1. So there is just F which is giving us C, right? And the rest of it is below C. So obviously the average out will be coming out to be something lower than 30. So global also, I actually don't have to check. So I can just strike this out, right? I mean, I need some of the grades more than C in order to get in the range of 31 to 40. What about high Q? Now high Q, again, I'm seeing there are C, D, D, and this B. This is the only grade that is available to me, which is more than 30. So it's actually 40. B is 40. So that is the only one which is contributing to it, isn't it? Now, whether this will be satisfied or not, let us look at the weights that are available to us. So HiQ has 30 contributed by one weight. So these are the grades and these are the weights. So I can use deviation technique if I require, but then I'll come to that in a while. So grade 30 is having a weight of 1. There are couple of D's here, and the total weight that we are getting for D is 6, right? So 4 from R and 2 from P. So this is as a weight of 6, and 40 has a weight of 3, isn't it? So this is the only 40 that we have for HiQ, right? So this I parameter has a B. Now, don't involve the 30 to begin with. Just use some bit of logic. Check this part out. If I average out 40 and 20 in the ratio 1:1, then I will get an average of 30, isn't it? Simple average. But here the weight is stronger for this 20 grade. So that will pull it below 30, right? So just imagine it in terms of pulls. So 20 is being pulled by 6 people and 40 is being pulled by 3 people, something like that. So if there would have been equal people, then ideally, I mean, each people having the same strength or something. But if I had equal people, it would have balanced out at 30, right? But because 6 people are pulling it, so it will go below 30. So this one will average out below 30. And then you have this 30, whatever be the weight. So final average, when we calculate of this net, you will get something that is below 30. So HiQ is also ruled out. So H is also gone. Similar kind of thing is happening here as well, right? As in HiQ. So even in this case, in dominance, that is. So let me just remodify this. Let me just quickly change the weights here, because the similar kind of thing is happening for dominance also. I hope you can see. So for dominance, you can see that a couple of D's, total weight of 5. B is having a weight of 2, because this is having a weight of this 2. And 30 is having, so C is having a weight of 3 here. Again, leave this 30 as of now. Again, check the same thing. So 20 has a higher pull, right? So there are 5 people, there are 2 people here. So again, it will go below 30. So dominance is also not falling in this range. So this is also out. I mean, Cosmopolitan also has the same kind of problem. So B, 1B and couple of Ds. So 1B has a weight of 1 here, because that is what we can see up top. F parameter has a weight of 1. So you have 40 pulled by 1 person, and this 20, couple of D's here, that is being pulled by 6 people. So again, this will fall below 30, right? So Cosmopolitan is also out. Similar way, you can evaluate this bested. So bested, I just take these things off. Yeah. So bested, you can see that again, there is only 1 person pulling this 40. And there are 5 people pulling this 20. Again, this will fall below 30, right? So each of these things, I mean, is going to be below 30, right? The grades are going to be below 30. And we know the remaining 3 colleges have grades greater than 45, right? So that was in AA category. So there are no colleges which are falling in this range of 31 to 40. So the answer to this is option D. So that's it for this set. I'll just leave you with a bit of analysis. So initially, the thing that we solved, it can be actually done very quickly. So provided you are good with allegation and weighted average, the second part of this question solving becomes easy. So if you can analyze the initial part quickly, I did it in using 2 informations only. If you don't catch it in 2 information, using the third information, you'll definitely be able to solve it. So I would say the initial solving part would take somewhere in the range of 2 to 3 minutes, because it will not take more than that. Maybe 4 minutes. I'll put it as 2 to 4 minutes. If you don't identify those things quickly, you might be calculating or writing too many equations. In that case, it might go up to 4 minutes, but ideally you should do it in 2 to 3 minutes. Now, depending on your understanding of allegation and understanding of weighted average, this second part, the questions, when you're solving the questions, because there was something to solve in each of the last 3 questions, right? First question was very direct. You just have to find the weight of faculty equality parameter, and that was initially figured out. But the next 3 questions, for that, if you are good with allegation techniques and weighted average techniques, that becomes a little easier. So it would depend on your, how much acquainted you are with those kind of ideas. So depending on that, this will take around 3 to 4 minutes. So these 4 questions would take somewhere in the range of 3 to 4 minutes. Because I hope you can understand the last question even. I mean, the last one was the, you can say the most calculative out of the three, right? But if you do it in this way, the way I explained, you can directly observe and mark the answer as zero. You don't even have to calculate a single line. So all you have to do is just observe quickly. So that B thing that I was talking about, global will be directly out, and but the remaining you have some B, but then the B pool is very low. So obviously it goes below 30. So if you just observe that, it becomes very easy to solve. So I would say roughly for this set, the total time will be 5 to 8 minutes, and that should be an ideal time to solve this set. It is an easy set. There's nothing to it. Just that it might be calculative for some people. So I'll just write that. Maybe calculative, something like that. It should not be. The time you're taking CAT, you should be well adept with these simple ideas of offsets and deviation, because these are very basic ideas you should be well adept with. So that's it for this set. Hope you enjoyed. Thank you.